The machine is a masterpiece of Soviet engineering, a nuclear-powered predator designed to hold a nation hostage from the bottom of the sea. It is 1978, and its captain, a veteran of the silent service, believes he is a ghost, an invisible and untouchable instrument of state power. But a sound is coming from the darkness, a sound that is not a sound, a presence that is not a presence, and it will shatter his world. The year is 1978. The location is the deep, crushing darkness of the North Atlantic, in a region known to naval strategists as the Bermuda Box. This is a massive, featureless expanse of ocean off the eastern coast of the United States, a designated patrol zone where the fate of the world hangs in a delicate, silent balance. Down here, 400 meters beneath the turbulent surface, the pressure is enough to snap a human spine like a dry twig. But for the crew of the Soviet strategic missile submarine, a Project 667B Navaga, known to the West as the Yankee-class, this immense pressure is home. Captain First Rank Valery Geravev stands in the command center of his vessel. The air is thick, recycled, smelling faintly of ozone, of diesel oil, and of the collective sweat of 120 men living inside a sealed steel tube. The lighting is a dim, functional red, casting long, dancing shadows over the dials and the gauges that are the only eyes and ears of his submerged world. Geravev is a veteran. He knows his boat. He knows that the Navaga is a powerful instrument, a vessel capable of carrying 16 R-27 Zybe ballistic missiles, each one a single, terrible note in the complex and terrifying symphony of global power. His orders are as simple as they are terrifying: remain invisible, patrol the American coast, and wait for the coded order that he and the world hopes will never come. To Captain Geravev, his submarine is a predator. He believes, with the full confidence of his training and his faith in Soviet technology, that he is a ghost in the water, sliding silently through the deep, thermal layers of the Atlantic, completely and utterly undetectable. He pictures the Americans up there on the surface, their ships and their planes, endlessly scanning with their radar and their satellites, searching for a wake that isn't there. He is confident. But then the impossible happens. It does not begin with an explosion. It does not begin with a siren. It begins with a subtle hesitation in the familiar rhythmic pulse of the ocean. The sonar operator, a young warrant officer named Petro, suddenly lifts his headphones from one ear, his face pale in the green, washed-out glow of his scope. He looks over at the captain. He does not speak immediately. In the silent service, you do not speak until you are absolutely certain, because uncertainty is a contagion that breeds panic. "Comrade Captain," Petro whispers, his voice barely audible. He presses the headphones back to his ears as if trying to physically push the sound into his brain. "I have a transient, astern, in the baffles." Geravev moves quickly to the sonar station. "Identify." "Gone," Petro says, his own voice now trembling slightly. It was a mechanical transient, a single metallic click, like a hatch closing, but it was faint, ghostly. Geravev frowns. The baffles. This is the blind spot, the cone of acoustic deafness directly behind the submarine, where the violent churn of their own twin propellers and the roar of the turbulent water they create deafens their own sonar. It is a fundamental law of submarine physics as they understand it. Nothing can see through the baffles, and therefore nothing should be in the baffles. To be in the baffles of a moving submarine, an object would have to be matching their speed perfectly, maneuvering with an impossible, suicidal precision in the blind, churning wake of a two-propeller drive. "Biological?" Geravev asks. "The ocean is full of strange noises, whales snapping shrimp, the shifting of thermal layers." "No, Captain, it was rhythmic. It was mechanical, then it just vanished. Gerevev orders a standard systems check. They are rigged for quiet running, or so they think. The Yankee-class submarine is a powerful machine, but it is not a silent one. It hums with the brute industrial force of its twin nuclear reactors. The captain, unable to find a rational explanation, dismisses it. It must have been a biological anomaly, or perhaps a strange acoustic reflection from the seabed, a thermal layer bouncing their own noise back at them. Hours pass. The submarine continues its slow, patient, underwater patrol pattern. But the mood in the command center has shifted. The air feels heavier, the silence more tense. Then it happens again, and this time it is not a sound, it is a sensation. The boat shifts slightly, as if caught in a current that shouldn't be there. The hydrodynamics of the water flowing over the hull just feel wrong. Petro at the sonar station stiffens. "Contact," he hisses. "Transient signal, very close, astern." It sounded like flow noise. Something just displaced the water right behind us. Gerevev feels a cold, prickling sensation on the back of his neck. He glances at the depth gauge. They are deep. There are no surface ships here. There are no fishing trawlers. If there is something big enough to displace the water directly behind them, it has to be submerged, and it has to be very, very close. The quiet, simmering anxiety in the command center has now crystallized into a cold, palpable fear. Captain Gerevev, a man whose entire career has been built on the principles of logic and control, is now faced with a phenomenon that defies both. He gives the one order that his training dictates in such a situation: perform a check turn. This is a standard, if aggressive, maneuver. The submarine will turn sharply to the side, a move designed to clear the baffles, allowing its own powerful sonar arrays, which are mounted on the bow and along the flanks of the hull, to sweep the area that was previously hidden by the engine noise. The hull of the great submarine groans in protest as the rudder bites into the black, dense water. The boat banks like a ponderous aircraft. The sonar array sweeps the dark ocean behind them. The operators listen with an almost painful intensity. They are listening for the telltale signature of another submarine, the hum of a reactor, the whine of a turbine, the rhythmic beat of a propeller. Silence. The green line on the sonar screen revolves endlessly, painting nothing but the empty, cold void of the Atlantic. There are no contacts, no metal signatures, no engine hum. "Clear, Captain," Petro reports, but his voice is unconvinced. The ocean is empty. Gerevev exhales a long, slow breath he didn't realize he had been holding. Of course it is empty. It had to be a glitch, a phantom echo from a strange thermal layer. He orders the boat back to its original course. They return to their patrol, but the mystery and the unsettling feeling of being watched does not leave them. Over the next 48 hours, the impossible events begin to compound. The experience transforms from a simple, unnerving mystery into a form of slow, burning psychological torture. At one point, the passive sonar picks up a strange and inexplicable hole in the ocean's background noise. It is as if a massive, silent object is moving through the water directly behind them, physically blocking the ambient, omnidirectional sounds of the sea, yet emitting no noise of its own. It is a black hole in the soundscape. The question hangs in the recycled air of the submarine. How can a machine of war, a thing made of steel and valves and powerful churning pumps, move through the water without making a sound? It seems to defy the very laws of physics as the Soviets understand them. The crew, their nerves frayed, begins to whisper in the mess halls and the bunk rooms. They talk of secret American weapons. Some of the older, more superstitious sailors talk of sea monsters. Others, more pragmatic, begin to talk of their own equipment failing, of a fault in the sonar that is making them all go mad. The political officer, a man whose job is to enforce ideological certainty, tries to maintain discipline. He delivers stern lectures on the unquestionable superiority of Soviet technology, but even he has started to look at the bulkheads with a new and unsettling suspicion. Then comes the incident that nearly breaks them. It is day 3 of the ghost phenomenon. The sea is rough on the surface, far above, but down here, in the deep, it is perfectly calm. Suddenly the sonar shack erupts in a cacophony of alarms. "High-frequency ping!" Petro shouts, his voice cracking with a mixture of terror and disbelief. "Single burst! Close range!" Geravev spins around. An active sonar ping is an unambiguous act of aggression. It is a shout in a dark and crowded room, a challenge. Someone is actively painting them with a beam of sound, trying to get a precise fix on their location. "Range and bearing," he demands. "Directly below us, Captain. The range is 0. The command center freezes. 0 range. That is an impossibility. That would mean that the source of the ping is physically touching their hull. "It's gone," Petro whispers, his voice now terrified. "Just one single ping, like they were just checking the distance." Geravev grips the railing in front of him, his knuckles white. His heart is hammering against his ribs. This is not a glitch. This is not a natural phenomenon. This is an act of intelligence. Something is out there. Something is toying with them. It is watching them. It is measuring them. And now it has perhaps even touched them. And yet it still refuses to be seen. The fear is no longer just about being found. It is about the total, abject, and terrifying inability to understand the thing that has found them. When Captain Geravev and his submarine, the Navaga, finally returned to port in the grey, freezing waters of the Kola Peninsula, the mission is, on paper, a technical success. They patrolled their designated area, they remained unengaged, and they returned safely. But the deep psychological toll on the command crew is visible. They look like men who have just seen a ghost. The official investigation that follows begins not as a scientific inquiry, but as an interrogation. In a stark, windowless room in the naval base at Gadzhievo, a room that smells of stale tobacco, smoke and wet wool, Geravev faces a panel of senior officers from the Northern Fleet and a stern, unsmiling representative from the GRU, the Soviet military intelligence. The Soviet system does not reward the reporting of unexplained phenomena. Unexplained phenomena are treated as errors, and errors in this system are often treated as crimes. "Repeat your statement, Captain," the Admiral on the panel says, his voice flat and devoid of sympathy. He taps a thick, classified file on the metal table. "You are claiming that you were tracked for 3 days by a vessel that showed no sonar return, made no engine noise, and could maneuver inside your own baffles while you were performing evasive turns." "Yes, Comrade Admiral," Geravev says, his own voice steady, his gaze unwavering. "And yet," the Admiral continues, leaning forward with a theatrical sigh, "your own acoustic tapes show nothing. We have analyzed them. They show only the ocean, only the normal background noise of the Atlantic. Are we to believe in phantoms, Captain? Or are we to believe that your sonar operators were hallucinating from fatigue?" This is the central Soviet dilemma. The evidence of the American presence is a negative evidence. It is the very absence of the normal expected readings that had so terrified the captain. But the bureaucracy, the system, demands positive proof. The tapes are played again. The room fills with the familiar oceanic hiss of static. The experts point to the spikes on the graph. "Here," an acoustic analyst says, pointing to a jagged line. "Biological, likely a pod of whales." He points to another anomaly. "And here a thermal layer distortion. The captain interpreted a piece of natural oceanography as a hostile contact." The verdict is as humiliating as it is predictable: pilot error, paranoia. The crew of the Naval is officially reprimanded for filing false and alarmist reports. Captain Jaravev is not stripped of his command, but a permanent black mark is placed next to his name in his service record. He is sent back out to sea, a man who has seen the impossible and who has been punished for telling the truth. As the Soviet committees argue in Moscow, analyzing charts and blaming sunspots, the crews on the front lines are left in a state of high anxiety. The sailors know the truth. They know the ghosts are real machines. In the mess hall of a Delta-class submarine, a sonar man whispers to his friend, "It's not a satellite. I heard it breathe when we stopped. It stopped. When we moved, it moved. It's a hunter, and it's laughing at us." While the Kremlin was paralyzed by this paranoia, conducting witch hunts for saboteurs and theorizing about space lasers, the real answer to the mystery was sitting quietly in a dry dock 4,000 miles away. The location is Groton, Connecticut, home of the General Dynamics electric boat shipyards. The year is 1976. If the Soviet submarine program was a great, roaring forge of brute industrial strength designed to punch its way through the ocean, the American program of the same era was becoming something else entirely. It was a laboratory of silence. In a restricted hangar, illuminated by the bright, actinic sparks of welders and the low hum of industrial ventilation, American engineers were putting the finishing touches on a machine that would not just change, but completely redefine the rules of naval warfare. They called it the 688 class, which would become known as the Los Angeles class. To the untrained eye, it looked like any other modern submarine, a long, black, powerful steel cylinder. But inside its hull, the philosophy of its construction was utterly alien to the Soviet mind. The Americans had realized decades earlier that in the deadly calculus of the nuclear age, speed was secondary to stealth. If you are fast but loud, you are just a noisy target. But if you are slow and silent, you are a hole in the water. You are a ghost. The first great secret to the ghost that so terrified Captain Jaravev lay in a concept known as rafting. In a Soviet submarine of this era, the massive, powerful machinery of the engine room, the turbines, the reduction gears, the coolant pumps, were all bolted directly to the structural frames of the hull. When a Soviet turbine spun, the vibration traveled through the bolt, into the steel of the hull, and radiated out into the ocean like a bell ringing. This is why Jaravev's boat, for all its power, hummed. It was acoustically a ringing bell. The engineers of the 688 class did something radical, something that the Soviets considered to be madness. They built the entire engine room, hundreds of tons of heavy vibrating machinery, on a single, massive floating platform inside the submarine. This platform, or raft, sat on a complex and carefully engineered system of rubberized sound isolation mounts. The machinery never directly touched the hull. The vibrations were absorbed by the rubber. The hull remained acoustically dead. The Los Angeles class was not just a ship. It was a thermos bottle of sound. A sailor could drop a heavy wrench in the engine room, and a sensitive sonar operator on an enemy ship 10 miles away would hear nothing. But silence was only half of the equation. To be a true ghost, you must be able to see without being seen. And this is where the second great American technological dominance truly left the Soviets in the dark ages. The Soviet investigation had failed in part because they assumed the Americans were limited by the same immutable law of physics that governed their own boats. The problem of the baffles, the acoustic blind spot behind the submarine's own propellers. They assumed that to track Jaravev, the American submarine would have to be off to the side or even in front of him. They were wrong. The Americans had deployed the AN/BQQ-5 sonar suite and, crucially, the towed array. Imagine a thick, black cable over half a mile long spooling out from the tail of an American submarine. This cable is not a simple wire. It is studded with hundreds of highly sensitive hydrophones, underwater microphones. By trailing this long cable far behind the submarine, the sensors are physically removed from the noise of the submarine's own propeller. They are out in the clean, quiet water, listening. This was the magic that allowed the Americans to see through the blind spot. The Los Angeles-class didn't need to move to the side to listen. It could sit directly behind a Soviet submarine in the one spot the Soviets thought was perfectly safe, trailing its long, sensitive ear for miles back, listening to the Soviet captain breathe while the Soviet sonar looked backward and saw nothing but its own empty wake. The stage was set. The Soviets were confused, paranoid, and looking in all the wrong directions. The ocean was about to get much more crowded, and the predator was about to reveal its teeth. But it would not be a monster. It would be a machine so precisely and so quietly engineered that it had effectively removed itself from the universe of sound. To truly understand the impossible events that so terrified Captain Geravev, we must now shift our perspective. We must leave the dim, sweaty confines of the Soviet command center and enter the cool, blue-lit world of the hunter. Let us meet Commander James "Red" Harrison, a composite character representing the aggressive and supremely confident skippers of the American attack submarine fleet of the era. He is the commanding officer of the USS Batfish, a Sturgeon-class submarine, a predecessor to the 688 class, but one that has been upgraded with the new, revolutionary ears of the towed array sonar. The scene in Harrison's attack center is the polar opposite of the one on Geravev's boat. It is not a place of dim lights and anxious whispers. It is a cool, quiet, and intensely focused space illuminated by the calm blue glow of new digital fire-controlled screens. There is no shouting. The discipline is absolute, born not of fear, but of an unshakable confidence in their own technological and tactical superiority. "Con sonar," a voice comes over the headset, the tone casual, almost conversational. "Contact Sierra 1 is holding steady. Range 4,000 yards. Classification is a Yankee-class nuclear ballistic missile submarine." Commander Harrison sits in his command chair, sipping a cup of black coffee. He is not staring anxiously at a raw oscilloscope. He is looking at a waterfall display, a cascading digital readout of sound frequencies. To him, the Soviet submarine is not a mysterious ghost. It is a loud, clanking, and beautifully legible factory. He can see the sharp, clear frequency line of the Soviet boat's 50 Hz power plant. He can hear the specific, rhythmic rattle of what is likely a loose bearing on their starboard propeller shaft. He knows the Soviet submarine, in this moment, better than its own captain does. "Very well," Harrison says softly, his voice a low, calm murmur. "Maintain trail position, stay in his baffles, match his speed, 6 knots. This is the impossible event from Captain Geravev's perspective, now seen from the other side. The Ghost was simply a highly trained and supremely well-equipped American crew, utilizing a superior understanding of physics to sit in the one spot the Soviets thought was perfectly safe. When Geravev ordered his desperate check turn, the crazy Ivan swinging his massive boat to the right to clear his blind spot, he thought he was being clever, aggressive. On the American submarine, the sonar computer instantly registered the change in the Soviet propeller's pitch long before the boat itself had even begun to turn. "Sierra 1 is shifting his rudder," the sonar chief reports, his tone still casual, almost bored. He's clearing his baffles, crazy Ivan to starboard. "Gentle rudder left," Harrison orders, without a trace of alarm. "Drift out, let him pass." The American submarine, silent on its rubberized machinery mounts, simply glides to the side, anticipating the Soviet maneuver. The powerful, active sonar blast from the Yankee-class, the ping, that had so terrified Geravev's crew hits nothing but empty water because the American submarine has already anticipated the move and is no longer there. They are dancing a waltz in the dark, but only one of the partners knows the steps. As soon as the Soviet vessel straightens out its course, the American submarine, which has been waiting silently off to the side, simply slides back into its comfortable and invisible position in the baffles. It was a game of cat and mouse, but the mouse was blindfolded and the cat was wearing night vision goggles. But the American advantage went even deeper than just the hardware. It was computational. In the late 1970s, the Soviet Union was lagging severely in the field of microcomputing. Their sonar processing was still largely analog, a system that required highly skilled human operators to stare at raw, unprocessed oscilloscope waves and to interpret the sounds with their own ears and their own intuition. The Americans, by contrast, were digitizing the ocean. The powerful computers aboard the Los Angeles-class and the upgraded Sturgeon-class submarines could take in millions of bits of acoustic data every second and filter it with an incredible and ever-growing library of algorithms. They could subtract the sound of the rain on the surface, the sound of the shrimp in the deep, the sound of the distant waves, leaving only the pure, artificial, and unmistakable frequency of the enemy machine. This computational power allowed the Americans to do something that was, to the Soviets, a form of black magic. They could perform a target motion analysis without ever emitting a single telltale ping of their own. Using complex mathematical algorithms, they could calculate the exact range, speed, and depth of the Soviet submarine using only passive listening. They could generate a perfect real-time firing solution for a Mark 48 torpedo that would guide the weapon to its target before the Soviet captain even knew that he was under attack. The strange, transient noises that Captain Geravev had heard, the single metallic click of a hatch, were most likely the mundane sounds of the American crew going about their daily lives. Perhaps it was a dropped tray in the galley or the sharp, hydraulic sound of a toilet flush valve. These were the small, insignificant noises that were usually suppressed under the rules of ultra-quiet, but which would occasionally slip out. The fact that Geravev could hear a toilet flush but not the 6,000-ton nuclear submarine that was carrying it is a stunning testament to just how quiet the American hulls had become. The American mission during this period was known as Hold Down. The strategic objective was simple: to prove that the Atlantic Ocean was, for all practical purposes, a NATO lake. Every time a Soviet missile submarine left the safety of the Kola Peninsula, an American attack submarine would be waiting for it at the Guyuk Gap choke point. They would pick up the trail, and they would never, ever let go. For days, and sometimes for weeks, the American submarine would shadow the Soviet boat. They would record its unique noise signatures. They would map its patrol patterns. They would practice simulated torpedo shots. To the American crews, this was a point of immense and swaggering professional pride. They were the cowboys of the deep. They wore sneakers on board to reduce noise. They grew beards. They worked punishing 18-hour days. And in the quiet, confident corners of their minds, they knew that they were invincible. The silent, one-sided hunt in the dark continued for years, a total and unacknowledged triumph of American engineering and daring. The Soviets were spending billions on the wrong things, chasing phantoms with space lasers and blaming their own equipment, while the Americans were in effect reading their mail over their shoulders. The mystery of the shadow was not solved in the cold, deep waters of the North Atlantic. It was solved in a nondescript, brightly lit room in Moscow, under the harsh glare of a fluorescent light, amidst a pile of stolen and incredibly valuable documents. The year is 1981. The breakthrough for the Soviets did not come from one of their own scientists inventing a new, revolutionary sensor. It came from an American traitor named John Anthony Walker. Walker was a chief warrant officer in the United States Navy, a man who had held a top-secret security clearance for years. For over a decade, driven by greed and a sense of personal grievance, he had been walking into Soviet embassies and handing over the nation's most sensitive secrets in exchange for cash. He is often cited by historians as the single most damaging spy in the history of the American military. But among all the crypto keys, the technical manuals, and the tactical diagrams that he sold to the KGB, he handed them something that was, for the Soviet Navy, far more devastating and far more valuable. He handed them the blueprints of the American acoustic advantage. The shock moment, the moment of terrible, gut-wrenching revelation, occurred when a team of senior Soviet naval architects and KGB analysts finally sat down to correlate the data from Walker's stolen documents with the years of frustrating and inexplicable reports from captains like Gerevev. For years, the Soviet Admiralty had convinced themselves that the Americans must be using some exotic, still undetected physical principle to track their submarines. They had theorized about radiation detectors, about wake sensors, about technologies that did not yet exist. Walker's documents shattered this collective delusion with a single, brutal truth. The documents revealed that there was no magic, there was no super sensor. The Americans were simply, and with a devastating effectiveness, just listening to their propellers. Specifically, Walker's documents revealed that the Americans had perfected the art of detecting cavitation at ranges the Soviets had thought were a physical impossibility. Cavitation is a phenomenon that occurs when a propeller spins so fast that it creates tiny, low-pressure bubbles in the water. When these bubbles collapse, they snap shut with a loud, distinctive acoustic crack. The stolen American charts that the Soviet engineers were now staring at with a growing sense of horror showed that the American attack submarines could not just hear this cavitation, they could classify a Soviet submarine's individual propeller blade rate from 50 miles away. They could tell if a propeller shaft was slightly misaligned. They could even, with a high degree of certainty, identify individual vessels based on the specific, rhythmic hum of their engine room pumps. Admiral Gorshkov, the powerful and revered father of the modern Soviet Navy, reportedly read the final assessment from this analysis and turned pale. The realization was absolute, and it was terrifying. The entire Soviet submarine fleet, hundreds of vessels, the product of billions of rubles of investment, the pride of a superpower, was not a stealth force at all. It was a fleet of drums, banging loudly in a global library. Captain Gerevev's terrifying experience was at last, finally, explained. The strange, transient sounds he had heard, that was the American submarine, the Batfish, maneuvering close to him, its crew so confident in their own invisibility that they were no longer observing perfect noise discipline. The reason the ghost had seemed to disappear when he made his turn, the Americans knew his blind spots better than he did, and the reason they could never find a tracking device attached to his hull, there was no device. The submarine itself, with its noisy, cavitating propellers, was the beacon. This was the Pearl Harbor of the Soviet Navy, but it was a Pearl Harbor that had happened in slow motion over the course of a decade, without a single shot ever being fired. The Soviet High Command now realized that in the event of a real war, their entire ocean-going ballistic missile submarine fleet, the ultimate insurance policy of the Soviet Union, would have been systematically wiped out in the first 48 hours of the conflict. The American attack submarines would have been waiting silently in their baffles, their torpedo tubes flooded, ready to fire the moment the order came. The carefully constructed balance of terror was a myth. The Americans had been holding a loaded gun to the Soviet head for years, and the Soviets hadn't even known the gun was in the room. The keys to their kingdom had been handed over, and the kingdom, they now realized, was defenseless. The revelation of their own acoustic nakedness triggered a frantic and desperate panic within the Soviet military-industrial complex. Now aware of the fatal flaw at the heart of their submarine fleet, they launched an emergency top-priority program to quiet their vessels, but they immediately slammed into a hard and unforgiving technological wall. Their heavy industry, so proficient at casting massive steel hulls and forging powerful reactor vessels, lacked the delicate, fine-tuned precision required to make a truly silent propeller. To make a silent propeller, you must be able to machine the complex curved surfaces of the bronze blades to a tolerance of less than a fraction of a millimeter. The curve must be perfect, the surface absolutely smooth, to allow the blade to slice through the water without creating the noisy, telltale bubbles of cavitation. The Soviet Union's existing milling machines were simply not accurate enough. They were a product of the industrial age, while the Americans were already deep into the digital age. This technological deficit led to one of the most audacious and desperate industrial espionage operations of the entire Cold War, the Toshiba-Kongsberg scandal. In 1982, knowing that they could not build the necessary machines themselves, Soviet intelligence agents approached the Japanese company Toshiba Machine and the Norwegian company Kongsberg Våpenfabrik. Through a complex and illegal web of lies of front companies and of falsified export documents, they managed to secretly purchase 9 advanced multi-axis computer-controlled milling machines. This was a technology that was strictly embargoed for sale to the Soviet bloc by COCOM, the International Coordinating Committee for Multilateral Export Controls. These massive, state-of-the-art machines were smuggled, piece by piece, into the Soviet Union. They were set up in a specially constructed secret facility at the Baltic shipyard in Leningrad, and for the first time, Soviet engineers were able to carve their own submarine propellers with the same computer-aided micron-level precision that the Americans had been using for years. The impact was immediate and dramatic. The new, quieter propellers were fitted to the next generation of Soviet submarines, the Akula-class and the Sierra-class attack submarines, and the upgraded Victor III-class boats. When these new and improved submarines first put to sea in the mid-1980s, the American acoustic advantage suddenly and alarmingly began to shrink. The acoustic daylight, the term the American submariners used to describe the massive gap in quieting technology, began to dim. American sonar operators, who were used to hearing the loud banging presence of Soviet submarines from counties away, suddenly found themselves having to work much, much harder. The loud, clanking factory had been replaced by a much fainter, more difficult to detect hum. But this was, in the end, a futile response. It was a band-aid on a massive, hemorrhaging wound. The shock of the Walker revelations had come too late. By the time the Soviets began to quiet their propellers in the mid-1980s, the American economy and its technological base had already leaped forward again. While the Soviets were celebrating their new, quieter propellers, the Americans were already deploying their next nightmare, a new generation of digital sonar processors, of satellite oceanography, and of advanced computer processing that could, in some cases, detect the absence of background noise, the very hole in the soundscape that had so terrified Captain Juravev years before. More importantly, the strategic damage had already been done. The Soviet leadership had lost faith in their own deterrent. The psychological impact of the Walker revelations was so profound that it crippled their confidence in their ability to operate in the open ocean. This led to a massive and fundamental shift in their naval strategy, a great strategic retreat known as the Bastion concept. Instead of prowling the Atlantic and threatening the American coast, the bulk of the Soviet ballistic missile submarine fleet was now ordered to retreat. They pulled back into the heavily defended waters of the Barents Sea and the Sea of Okhotsk, vast areas that they could turn into protected fortresses or bastions. Here they would hide under the Arctic ice cap, protected by a dense, layered ring of their own surface ships, aircraft, and attack submarines. This was not a strategic redeployment. It was an admission of defeat. The great blue water navy that Admiral Gorshkov had dreamed of, a navy that could challenge the Americans for control of the world's oceans, was dead. They were now forced to hide in their own backyard because they knew that out in the deep, open water, the silent, invisible shadow of the American attack submarines was still waiting for them. The futile nature of their response was best summarized by a defecting Soviet naval officer years later. He noted that while the Toshiba machines had made their propellers quieter, they couldn't fix the noisy pumps, the rattling gears, or the loud reactor flow noise without completely rebuilding the entire submarine from scratch. "You can put silent tires on a noisy truck," he said, "but the engine will still rattle." The Cold War did not end with a nuclear mushroom cloud rising over New York or Moscow. It ended, in many ways, in the quiet, unforgiving columns of the accountant's ledger. And nowhere was the fatal deficit of the Soviet system more terrifyingly obvious than in the silent underwater war. The verdict of this decades-long game of cat and mouse can be summarized in one single, devastating statistic, a number that remained classified as top secret until long after the Berlin Wall had fallen. In the mid-1980s, in the wake of the Walker spy ring revelations and the subsequent analysis of Soviet naval exercises, American naval strategists ran a series of complex computer simulations of a hypothetical Third World War. The parameters were simple. The Soviet Union launches a surprise first strike. What happens to their ballistic missile submarines, their ultimate strategic reserve, in the Atlantic? The result was a kill ratio that stunned even the most hawkish generals in the Pentagon. The simulation predicted that within the first 48 hours of hostilities, before most of them could even complete their complex firing sequences, over 90% of the Soviet Yankee and Delta-class submarines on patrol in the Atlantic would be found and destroyed. 90%. This is the killer statistic. It is a number that renders the trillions of rubles that the Soviet Union had spent on its massive naval expansion effectively and tragically wasted. They had built the largest submarine fleet in human history. They had launched hundreds of hulls. They had trained thousands of dedicated and professional officers like Captain Jaravev. They had created a force that looked terrifying on paper and in the Grand May Day parades in Red Square, but in reality they had built a fleet of floating coffins. The ghost that Jaravev had encountered, the American attack submarine, sitting silently in his baffles, was not an isolated, lucky incident. It was the standard operating procedure. For nearly 2 decades, the United States Navy had achieved a level of quiet, underwater dominance that is rare in the long history of warfare. It was akin to an army marching into battle with invisible tanks. The impact of this realization on the Soviet Union cannot be overstated. It broke the back of their strategic confidence. When the Soviet leadership finally understood that their blue water navy could not survive in the open ocean, they were forced into the great strategic retreat of the Bastion strategy. But the economic consequences of this retreat were fatal. Because they now had to hide their submarines in the Barents Sea, thousands of miles further away from the American coast than the Bermuda Box, their old, existing missiles could no longer reach their targets in the United States. To hit Washington, D.C. from under the Arctic ice cap, they needed bigger, heavier, and longer-range missiles, and to carry these massive new missiles, they had to build massive new submarines. This necessity gave birth to the Typhoon class, the Project 941 Akula. It remains, to this day, the largest submarine ever built. It was a titan of steel, twice the size of its American counterparts, a vessel so vast that it featured swimming pools and saunas for its crew. It was a magnificent marvel of Soviet heavy industry, but it was also a catastrophic economic black hole. A single Typhoon-class submarine cost as much to build and operate as an entire city. And the Soviets, in their desperation, built 6 of them. They were, in effect, pouring concrete into the ocean. While the United States was investing in the microchip, in the nascent internet, and in the software revolution, technologies that would have both immense military and transformative civilian applications, the Soviet Union was bankrupting itself, trying to illegally purchase and reverse engineer the machines to mill silent propellers and welding together titanium hulls just to survive. This is where the mystery of the Phantom Sub connects to the macro theme of the Soviet collapse. It was a triumph of software over hardware. The American advantage was not that they had better steel, it was that they had better information. The Los Angeles-class submarine was a floating supercomputer with a propeller attached. The Soviet submarines were tanks with periscopes. And in the modern information-driven age, the computer always wins. The Toshiba Kongsberg scandal was the final humiliating admission that the Soviet system had failed. A superpower that could put a man in space but could not manufacture a silent propeller blade without buying the illegal, embargoed machines from its enemies is not, in the long run, a sustainable superpower. It is a hollow giant. And what of the men? Captain Valery Geravev and his generation of proud commanders were left to watch their empire rust away. When the Soviet Union dissolved in 1991, the mighty fleet that had once terrorized the Atlantic was simply abandoned. In the icy, desolate ports of the Kola Peninsula, in places like Olenia Bay, dozens of these nuclear-powered leviathans were tied up to the piers and left to rot. The Yankee-class boats, the very vessels that Geravev had commanded, were stripped of their missiles. Their still radioactive reactor cores were removed, often with American money under the Nunn-Lugar Cooperative Threat Reduction Program, and their massive hulls were cut up for scrap metal. It is a haunting and powerful image, the terrifying machines that had once held the entire world hostage, reduced to piles of jagged, rusting metal in the snow. The razor blades you may have used this morning might have once been the hull of a Soviet missile boat that had prowled the Bermuda box, hunted by a ghost it could never see.